Okay, let's look at some industrial applications of Le Chatelier principle or chemical equilibrium. Number one we're going to be studying is the Haber process. We're studying actually the Haber process and the contact process. Now, Haber process is for the production of ammonia, a key ingredient of fertilizers. When you're making fertilizers, you need ammonia. Now, how do we apply the Chatelier principle to optimize yield in the process of production? Look at this equation. All the products here are gases. Now, in the production, in the Haber process, they use a pressure of 200 atmosphere, a high pressure of 200 atmosphere. And now remember, according to the Chatelier's principle, when gases are involved, high pressure will shift equilibrium to what? To fewer gases. And here we have 4 molecules of gases, we have 2 here, so it will shift to this side, and therefore it will favor the production of what? Ammonia. Equilibrium will shift to the right. Now, they use a temperature, a moderate temperature of 450 degrees Celsius to 500 degrees Celsius. Very moderate temperature. Simple reason being that if you use high temperature, because we have delta H equals to minus 92 kilojoules per mole. It means that if you use high temperature, you will favor the backward reaction. Because in exothermic reaction, high temperature favors what? Shifts equilibrium to the left. So in this case, they use moderate temperature. Because if you use a temperature that is too low, too slow, the reaction will be too slow. So they use moderate temperature, and the production of ammonia is also what? Favored. It shifts equilibrium to the right. Another thing we do is removal of ammonia from the system. If you remove ammonia from the system, you are going to disbalance the system. You have disturbed the system by removing ammonia. And when you remove the product, the reactor will want to balance the system back. It's actually a reversible reaction. The reactor will want to balance the system back by what? Reacting more to produce the quantity of ammonia that will stabilize the system and bring it to what? Equilibrium. Is that okay? So that is it about the Haber process. If you are finding it interesting, give us a follow while we proceed to study the contact process. Let's look at the contact process. Yeah, we're just simply looking at the application of the Chatelier principle in these processes. Let's look at the contact process. Contact process. Contact process is used for the production of tetraoxosulfates, normally called sulfuric acid. We'll take the key process, which is the reaction of SO2, all gases, with oxygen to form SO3 gas. It's a balanced equation. All right. In this equation, to maximize or to optimize production, what do we do? One, you use high pressure. In this case, they use a pressure that is slightly above atmospheric pressure. And because when you use high pressure, it shifts equilibrium to the sides with few gas molecules. That means here we have 2 gas molecules, here we have 1. So equilibrium will shift to the right and favor the production of what? SO3. 2, they use moderate temperature. Okay, here delta H is plus, delta H is positive. I've forgotten the value. So it is an endothermic reaction. So they use moderate temperature. And this moderate temperature is around 450 degrees Celsius too. Now, another condition is the removal of SO3 from the system. Removal of SO3 from the system. When you remove SO3 from the system, you are going to disturb the equilibrium position. And more of the reactor will react to produce the product so that the system can, the equilibrium position can be what? Restored. Now they use vanadium catalyst. They use a vanadium catalyst to speed up the rate of reaction without disturbing the system. So these are some industrial applications of Le Chatelier's principle. If you find this class interesting, give us a follow, like, comment, and share. And do not forget to follow so that you meet us in our next classes. A lot of videos also are loaded on the page. Go through them. I guess you'll find them interesting. See you in the next class.